Welcome, explorers. Step softly and keep your eyes wide open. We're embarking on a journey into a world hidden right beneath our fingertips, the wild, untamed habitat of Grade 7 technology. Specifically, we're tracking down mechanical systems and control. I'll be your guide for this explainer, and together we're going to observe these fascinating mechanical beasts in their natural environment. We'll study their anatomy, their behaviors, and exactly how they multiply human power. By the end of our expedition, you won't just understand these systems, you'll be perfectly adapted to survive that upcoming exam.
Before we hack our way through the dense underbrush, let's just quickly check our expedition map. We're covering 1. The anatomy of a lever, 2. Mastering mechanical advantage, 3. The 3 lever classes, 4. Linked lever systems, 5. Air versus liquid power, and finally, number 6, a final exam survival quiz. All right, Section 1, Anatomy of a Lever. Shh, step carefully here. Look just ahead, and we can observe one of the oldest, most fascinating species in the technological world, the simple lever.
To really understand this creature, we first need to define its taxonomy. Like, what exactly are we looking at here? Well, a mechanism is simply a set of moving parts that work together to make human tasks easier. They evolved purely to take the heavy lifting off our shoulders. And the lever? That is a remarkably simple mechanism. It's essentially just a rigid bar that pivots, or turns, on a single fixed point. It's elegant, it's efficient, and man, it's everywhere. Okay, let's dive into this and really break down its anatomy. Every single lever, no matter how massive or tiny, possesses 3 crucial body parts. First up, the fulcrum or pivot. This is the fixed turning point where the lever actually balances. Second is the effort or input force. Think of this as the power you, the human, apply to the system. And third is the load. This is the heavy burden, the actual weight of the object that needs to be lifted or moved. Moving on to Section 2. Mastering mechanical advantage. Now that we know what a lever is made of, let's examine its behavior in the wild. You're going to want to observe this secret code closely, explorers, because it frequently appears in the wild, and it's almost guaranteed to stalk you on your exams. Mechanical advantage, or MA, equals the load divided by the effort. Oh, and a quick note, both the force you put in and the load you're lifting are measured in a unit called newtons. This brilliantly illustrates the 3 possible states of our lever. Think of it as 3 different behavioral moods. When mechanical advantage is greater than 1, we're in a good state. This happens when the fulcrum is pushed way up close to the load. The result? You use way less effort to lift a heavy weight. The task becomes magically easier. But beware the disadvantaged state, where MA is less than 1. This happens if the fulcrum creeps too close to your effort. Suddenly, the task becomes much harder, offering literally no benefit to you. Finally, if the fulcrum sits perfectly in the middle, MA equals exactly 1. This is a neutral state. The effort you put in equals the load you get out. No true advantage is gained. The big takeaway here? Simply moving that fulcrum completely changes the power dynamics of the beast. We're making excellent time. Let's move deeper into the territory for Section 3, the 3 lever classes. In the wild, classification is entirely determined by one simple rule: which body part sits in the middle. To survive out here, you absolutely must memorize the mnemonic FLE. This tells you exactly what sits in the middle for classes 1, 2, and 3. For a first-class lever, the fulcrum is perfectly positioned in the middle, right between effort and load. You've seen these everywhere: snappy scissors, a claw hammer, or playground seesaw. Now, for a second-class lever, the load rests heavily in the middle. Picture a majestic wheelbarrow carrying dirt, or a mighty nutcracker. And finally, the elusive third-class lever puts the effort right in the middle. We see this with humble tweezers, a fishing rod, or a spade digging into the earth. Remember, FLE, fulcrum load effort. Make sure you burn that into your survival guide. Section 4, linked lever systems. So what happens when these solitary mechanisms stop hunting alone and start hunting in packs? Well, when levers team up, they form what's known as a linkage. This is an incredibly cooperative mechanical relationship. It consists of 2 or more levers connected by pivots, which, by the way, can be either fixed or moving, allowing them to work together flawlessly as a single unified system. They literally multiply their effectiveness just by joining forces. If you look around your own home, you'll spot these packs hiding in plain sight. A pair of scissors or pliers? That's a first-class linked system. That heavy-duty office hole punch? A second-class linkage hard at work. The stapler sitting on your desk is a third-class linked beast. But out in the wild, it gets even more fascinating. Complex linkages using more than two levers form the anatomy of everyday beasts like brytongs, the expanding metal of security doors, and even the folding legs of stepladders. Their complex multi-lever anatomy is hidden right beneath the surface. Now, tread very carefully, explorers. We are approaching the undisputed titans of fluid dynamics. In Section 5, Air versus Liquid Power. Both of these systems use pressure inside cylinders and syringes connected by pipes to transfer movement, but they have entirely different temperaments. Pneumatics run on compressed air or gas, and because air molecules have lots of empty space between them, air is easily squished or compressed. It kind of has a soft, yielding nature, meaning it provides less force and will actually give way under a heavy weight. But hydraulics use liquid, like water or oil, and the fundamental law of nature here is that liquid absolutely cannot be compressed. When you push liquid through a pipe, it delivers a massive, unyielding brute force. It's the apex predator of lifting power, capable of hoisting huge, massive objects like cars into the air with total ease. All right, team, shake off the dust. We've mapped the terrain, and now it's time for Section 6, the final exam survival quiz. Test yourself. We're shifting into high gear for a rapid-fire exam prep sequence. Trust your instincts? Here we go. Question 1. The foundational map of all technology. What is the precise correct order of the design process? Think fast. Boom. You investigate the problem, design a solution, make the product, evaluate if it works, and communicate your findings. 5 vital steps. Do not enter the exam jungle without them. Question 2. We're testing your knowledge of the visual language of mechanical sketches. When you see a thin dashed line on a drawing, what is it trying to tell you? It's hidden detail. That dashed line is whispering the secrets of the object, showing you the hidden edges that you can't actually see from the outside. Question 3. Let's see if you can handle tricky ratios. If a technical sketch has a scale of 1 to 3, is the drawing scaled up or scaled down? It is completely scaled down. Remember the rule here. The drawing is the 1 and the real-world beast is the 3. The actual object is 3 times bigger than the piece of paper. Question 4. Let's test that FLE mnemonic memory we just talked about. Picture a wheelbarrow hauling dirt across a garden. What class of lever is it? It is absolutely a second-class lever. Why? Because the heavy dirt, the load, is carried right there in its belly, perfectly positioned in the middle, between the wheel fulcrum and your lifting effort. And now, explorers, as the sun sets on our mechanical safari, I leave you with one final, provocative thought to ponder in the wild. If you need to lift something incredibly heavy, why exactly is a liquid hydraulic system the ultimate, unyielding beast of burden compared to an air-filled pneumatic one? Think about those squishy air molecules versus that rock-hard liquid. Keep that answer locked in your mind, and you will absolutely conquer your technology exam with flying colors. Keep exploring, and I'll see you on the next journey.